In this video, we're going to talk about the derivatives of the inverse trigonometric functions. So these are the derivative formulas for the inverse trigonometric functions. You've got the derivative with respect to x of the arc sine of u. That's going to be u prime divided by 1, the square root of 1 minus u squared. The derivative of arc cosine of u is negative u prime over the square root of 1 minus u squared. Notice that these two derivatives are the same except for the fact that you have a negative with the cosine. And in fact, if you look down the line, that's true for all of these. If you know the left-hand side, you just throw a negative at the top and you'll have the right-hand side. So the arc tangent, you're going to have u prime over the square over just 1 plus u squared. There's no square root here. This one you'll have u prime divided by the absolute value of u times the square root of u squared minus 1. And one way that you can kind of remember these is if you start out with the sine of x is equal to u, then if you write that as u over 1, then you would have u over 1 for the opposite over the hypotenuse, and this side would end up being 1 minus u squared. If you start out with the tangent of x is u over 1, if this is your x, you would have a u and a 1, and this would be u squared plus 1 squared, or 1 plus u squared. And if you start off with the secant of x is u over 1, then this would be the hypotenuse over the adjacent. So this one would be the square root of u squared minus 1 squared, or u squared minus 1. So you can see where these pieces are coming from. We're not going to go into the details of how to prove something like this is true, but you can see where the pieces of the triangle are coming from. When we get into chapter 8 in Calculus 2, you'll see this again, and so you'll kind of get a deeper understanding of where these formulas come from. But for now, you just need to know how to use them. So for the derivative of the arc sine of 3x, my u is going to be 3x, which means u prime would be 3. So this will be plugging in, I would have 3 divided by the square root of 1 minus 3x squared. So that'll be 3 divided by the square root of 1 minus 9x squared. And that's how I use that. The derivative of arc cosine, so this is the derivative with respect to x, again, of arc cosine of u. U is the square root of x, or x to the 1/2. So u prime is 1/2 x to the negative 1/2, or 1 over 2 square root of x. So this is negative u prime divided by the square root of 1 minus u squared, which is negative 1 over 2 square root of x, divided by the square root of 1 minus the square root of x squared. So that gives me negative 1 over 2 square root of x divided by the square root of 1 minus x. And I could clean this up a little bit. I would have negative 1 over 2 times the square root of x times the square root of 1 minus x. Some people would leave it like that. Some people would write it as negative 1 over 2 square root of x minus x squared. Honestly, either one of these is fine with me. And then one more of these that's kind of interesting. In this case, I've got the derivative with respect to x of the arc tan of u. So we know that this is going to be u prime over 1 plus u squared. U here is e to the 3x. So u prime is going to be the derivative of the exponent, which is 3 times e to the 3x. So this will be 3 e to the 3x divided by 1 plus e to the 3x squared, which is 3 e to the 3x divided by 1 plus e. Now when you raise a power to a power, you multiply, so that becomes e to the 6x. And that is your answer.